Hello, everyone. Mr. Minix, my name. Math is my game. Today we're talking about Texas Instruments topics. Dyslexia has been striking me all day long. TI topics. The final installment deals with regression modeling. Regression modeling. I'm just going to say regression models. Here we go. TI topics, regression models. For anybody that's OCD and the fact that I didn't recognize the TI into print, I'm sorry. Maybe I'll put a random dot on the screen too. Just a minute. No, I'm sorry. I better stop. That's cruel. All right, so anyway, today what we're going to look at is a data set. The data set that I've got going on today is this. It's going to be a table. It's going to have some X's in it. It's going to have some Y's in it. They're not sequential, so that's worth noting. They're not sequential. We'll go -2, 5. And then we got -1, 15. And then we've got 0, -2. And then we've got, it jumps from 0 on the X's all the way up to 3. It skips over 1 and 2. So then it goes to 3, -11. And then it goes 4, 1. And then from there it goes 5, 20. And then from there it goes 6, -2. And finally, the last point is 7, -100. Keeping it real. Keeping it 100, as they say. I don't say that, but that's what they say. Anyway, so our data set, what we're going to want to know is what model best fits the data? Question mark. What model best fits the data? And in math, when we say model, we're not talking about Ashton Kutcher or Naomi Campbell or Giselle Bundchen or Ertl. Anybody have any Ertl toys? Those little Tonka toys? Ertl makes them, I think. You know what I'm talking about? Okay. So anyway, when we talk about this, we're talking about equations. Is a line going to fit this the best? Is perhaps a parabola going to fit this best? Or are we going to need something that we studied in chapter 5? Something that goes whoop. I better have some kind of drawing to accompany that. Are we going to need something that looks more like this? Whoop. What are those called? It starts with a P. Not a parabola. Polynomial. We're going to need some kind of polynomial. And if it does need to be a polynomial, actually a line is a polynomial. A parabola is a polynomial. If it is a polynomial, what degree is it going to have to be? So those are the kinds of things we're going to be answering today. And when we say model, know that the word model just means equation. Okay, so we're going to try to come up with different equations. We're going to come up with an equation of a line. We're going to come up with an equation for a parabola, etc. And we're going to use the calculator to do this, thank goodness. All right. So, speaking of the calculator, here it is. Texas Instruments. I'm at the home screen. I'm starting up a new document, and I'm not saving the old one. Now, I need to organize my data. You might think to add page number 5. Don't. It's not page number 5. We need to organize our data. If you've ever used Microsoft Office, there's a green application that's called Excel. If you've ever used Google, there's a thing called Google Sheets that's just like Excel. That's what we're using. But on this TI-Nspire, it's not called Google Sheets and it's not called Microsoft Excel. It's called Lists and Spreadsheets. Add lists and spreadsheets. Option number 4. There it is. Bam. That looks just like Microsoft Excel, doesn't it? It's essentially the same thing. Now, up top, you'll notice that there's a tag up there. That means that's where we're going to put our labels. We have 2 columns of data. We have an X variable and a Y variable. So in column A, up near the tag, I'm going to go ahead and label that with an X. You would be very well advised to do the same. If you don't do this, everything that we do later on is going to be more complicated. So we're going to label that with an X. And we're going to label column B with a Y. And if you haven't figured it out yet, starting in cell A1, going all the way through whatever it takes, cell B9 or whatever it takes, we're going to enter the data now. Make sure your x's and your y's correspond. So take a minute and do that. Remember, the x's aren't sequential. It goes -2, -1, 0, and then the x's jump from 0 to 3. So we're actually going to be going from cells A1 through B8. What amazes me is how fast some people can type text messages, but how slow they are when it comes to punching things into a graphing calculator. Never ceases to amaze me. But it's not about speed, it's about precision, it's about accuracy. So make sure that everything is copacetic. After you enter that very last one, if you put the -100 in last, after that, make sure you press the enter button. If you don't press enter, the calculator is not going to actually put that in there. It's going to kind of be in a limbo state. So make sure you press enter after the last one. So take a minute, double check, make sure all your x and y coordinates pair up, match up. Make sure you got your -25, -115, 0, -2, 3, -11, 4, 1, 5, 20, 6, -2, and 7, -100. We doing all right so far? Good. So we've got that data, and earlier today in my class, I had a picture of Ed Bassmaster up. I don't know if this is going to come back through in the YouTube playback. It might not. I don't know. Sometimes it doesn't. Let's see. I'm going to turn up my volume here in class. So you guys know what this guy says, right? I don't know that that's going to play well with the smart software. So anyway, if it worked, fine. If it didn't, that's fine too. But sometimes we just got to look at it. In the data, what I want to do is I want to look at it. And when we look at the data, I mean, it's one thing to look at it there, but wouldn't it be nice if we could see a picture of this? In statistics class, the name of a picture of bivariate data, that's a big fancy word, bivariate. It means there's two variables. The name for that is for the picture is a scatter plot. And this is what makes this calculator so awesome. So we're going to go into our document. I'll press the doc button. We're going to insert into the document some kind of page that's going to let us make a scatter plot. Data and statistics. Nice, good. We're going to go to data and statistics, option number 7 on mine. And the calculator brings up this page and it says, click here to add variable, click here to add variable. You can use your directional pad and your mouse if you like. I'm going to press the tab button, and the tab button will snap to the bottom. It should, if all works well. I press tab and it snaps to the bottom, and I'm going to make this bottom thing my x variable. Now my recording software and my computer are all inundated right now with confusion. They don't know what to do. So I'm going to try, if it lets me, to make one of them X and make one of them Y. There, we got it. Okay. So that's what the data looks like. So I'll go ahead and take a screenshot of that. Do you guys know who Pee Wee Herman is? A lot of people think they know what Pee Wee Herman is or was. Pee Wee Herman, the movie was pretty funny, actually. Anybody ever see Pee Wee's Big Adventure? Great movie. One of the best movies of all time, in my opinion. Forrest Gump's pretty good too, yeah. All right, so this is what the data looks like. Now, right off the bat, do we think a line fits the data very well? No. But nonetheless, let's go ahead and fit a line to this. So to fit a line to this, what we're going to do from this page is we're going to go to the menu. And to find a regression model, we're going to have to do some analysis. We're going to analyze. Now, what's the title of today's lesson? Regressions. So which option here? Number 6, regression. Now, there's several different kinds of linear models. There's MX plus B, there's A plus BX, and there's median. We're going to start with the one that everybody in the world knows, mx plus b, right? So we'll go ahead, option number 1, show linear. Option number 1, show linear. And the cool thing about doing that on this particular page is, I don't know if you can see it or not, but the equation is written out for you. Y equals negative 5.8x plus 6.7. Does that make sense? Okay. So our linear model for this is y is approximately equal to, what do we say, negative 5.8x plus 6.7. Negative 5.8x plus 6.7. Okay. So far doing all right? Now there's a couple things that I'm going to get into in this lesson. If it goes right over your head, don't sweat it. If you take a statistics class, you'll need to know it. But I just want to show you mathematically how we can confirm, how we can show for sure that that line is a lousy fit and that the one we're going to pick in the end fits better. So what I'm going to do is I'm going to go back to the other page. Do you know how to get back to the other page? Control left. A couple other ways to do that would be to click on the tab above too. But anyway, so when I get back to here, it's possible to run the regression from right here. And to do this, you got to highlight both columns. To highlight the columns, you want to arrow all the way up. I said all the way up. And then arrow up again. Got him? Now I want to highlight the other column. Anybody remember what I do? I press shift. I press shift, S-H-I-F-T, shift, and then arrow over, and now I have both columns highlighted. If you don't do this, everything from here on is going to be a lot more difficult, okay? So I got both columns highlighted. I have all my data in. I'm going to go menu. This is a statistical concept that we're looking at. So we're going to go statistics. And we're making some kind of calculation. Actually, the calculator is for us. So we're doing a stat calculation. And just like we did last time, same thing, linear mx plus b. Linear regression mx plus b, boom. If you didn't highlight the lists, nothing here would be populated. The reason I have you highlight the list is everything that you need is already populated. You don't have to press anything else other than OK. OK. So it shows us our slope again, negative 5.8, shows us our y-intercept again, and I wanted you to mathematically see why this line doesn't fit so well. Do you see this number down here that's r squared? If we were to take the square root of that number, that's going to tell us a percentage of how well a line fits this. Let's think about the square root of 0.26. That's a 0.26 is about a fourth, right? And the square root of a fourth is about a half. So let's think about this on a grading scale. Is 50% good or not? 50% is not even passing, right? So what this is telling us is that a line is a lousy representation of the data that's there. Does that make sense? If we can somehow, some way, come up with an r squared value that's close to 1, let's think about that. What's the square root of 1? 1. 100% is as good as it gets, right? So if we can get an R value that's close to 1, that's going to be the best fit possible model. Does that make sense? Okay. So, do you guys know how to undo something on a computer? It's Control Z on a computer, it's Control Z on the calculator. Control Z, I'm going to undo it. I said Control Z. Okay. So, I just well, it should have undone that model. Control Z, whoop. I'm pressing all kind of crazy stuff now. Control Z. Control Z. I'm trying to undo my model. There it is. Okay. So maybe a line doesn't work so well. Maybe I should run a quadratic model. So from here, I'm going to go menu. I said menu. Statistics. Stat calculations. Quadratic regression. Quadratic regression. And OK. Now, the quadratic model has negative 2.5x squared. Why? So here's my quadratic. Here's my quadratic. Y is negative 2.5x squared, approximately. Negative 2.5x squared. plus 6.3x plus 6.3x plus 17.6 plus 17.6. So that's that model. And if I look down in the list, I'm anxious to see my R value. It's 0.5. The square root of a half is a little bit bigger than a half. Let's see. Here's where using the scratch pad's a good thing. I said not to use a scratch pad, but the square root of a half is about 0.7. A C is pretty decent, isn't it? So a quadratic should fit better than a line, but it's still not good. What I want to do now is I want to go out of my scratch pad. I want to go back to that other page. How do I get back to the other page? Control right. There we go. Okay. So maybe I want to see my quadratic. So I'm going to go Menu, Analyze. Do you see how option number 1 lets me hide the linear? I know the linear is lousy. I'm going to hide the linear before I do anything else. So I'm going to hide the line. And I go Menu, Analyze, Regression, Show Quadratic. There's my quadratic. And that fits. Actually, I don't think it's much better than the line, do you? Do you see how my equation doesn't show? The whole thing doesn't show? When you do this, you're probably going to want to run your regressions on this page. If you want to see your whole equation, I'm going to suggest that you have your calculator round everything to 3 decimal places. You remember how to round from yesterday? What is it? Home, 5.2, and I want to go on float. I want to change that to fix to 3. Good. I'll fix that to 3. And now, back into my current document, now I can probably see it a little bit better. Does that make sense? If you still need to see things more, it's possible to grab that equation. It's really hard. I can't do this on my smartboard, but if you put the cursor up here, do you see how the hand shows up? Do you see how a hand shows up on the equation? If you press the center click button, it'll close that hand, and then you can take the D-pad and drag that over to see more of the equation. Does that make sense? And then if you click again, it'll release the hand. Okay. Are there any questions so far? Okay, so it's pretty clear then that the line wasn't so good, and the quadratic wasn't much better. What should we try next? Quartic? Okay, let's try a quartic. And if you look at this, you notice that the graph kind of does this here, and the graph kind of does this here, right? And somewhere in the middle, these have to be connected. Let's think about our turning points. How many turning points does this graph have? 3 turning points. What is the least degree that the function should be? Remember when we studied this before we left for break? The degree probably should be 4. So let's try a quartic. I'll bet a quartic's going to fit nice. So let's go Menu, Analyze, Regression, Show Quartic. Dude, that's it, just about every single point. That's awesome. The equation's there. I'm going to go ahead and write it down. Y is approximately. So my quartic model, Y is approximately negative 0.4x to the 4th, negative 0.4x to the 4th, plus 3.2x cubed, or plus 3.3x cubed. These are approximate, I'm rounding. Minus 0.4x squared, minus 0.4x squared. I can't see the rest of the equation. What should I do? Can I drag this over? Like I said, I have a hard time doing that with my smartboard, but so then I got what, 20 minus 20.6x minus 20.6x, and then minus 1.4. Cool. Would everybody agree that that fits very well? What kind of R squared value would you expect to see? Remember that R squared earlier? We had a 0.5 in the 90s. Let's take a look. How do we get that? What do we have to do in the calculator? Yeah, we got to go to the other page and we got to run the regression there. So to run that regression here, I got to highlight those columns again. Just those 2. I just want to highlight those 2. I'm going to give an anti-shout out to my computer. Can I do that? An anti-shout out to my computer. I'm not happy with you right now, computer. And clearly you're not happy with me. Because it's not responding. I think its RAM is overloaded. Is it 0.996? 0.9995 something? Yeah. So our R squared value is really good when we run this quartic regression. If my computer ever lets my calculator compute this, I'll show it on here for everybody to see at home. Let's see, shift and over. I said shift and over. I said shift and over. Well, let's try without. Menu. Menu. Statistics. Stat calculations. Quartic regression. So I wasn't able to highlight this, so I know my X's are in column A, so I need A and then a bracket, bracket. Whoop, bracket, bracket. And then my Y's are in B, bracket, bracket. And this should do it. Okay. And my R squared, like we said, it's 0.996. Really good fit. About as good as it's going to get. Do we have any questions? Comments? Do you feel that you would be able to replicate all those steps on your own? If I give you a worksheet right now, well, you'll get a shot. It's been real. It's been fun. Shout out to my 5th period class for being pretty attentive on a Thursday that we should have had a snow day. Have a nice day. See you. Good.